cannot access external websites, so I am unable to provide specific details about the calculators available at the provided URL. However, I can discuss general types of electrical calculators and their uses. Understanding electrical calculations is crucial for safety and efficiency in electrical work. Electrical calculators can assist in determining appropriate wire sizes, conduit fill, voltage drop, motor full load amps, and other essential parameters. Firstly, Ohm's law calculators are fundamental. Ohm's law describes the relationship between voltage, current, and resistance in an electrical circuit. The formula is voltage equals current times resistance, or volts equals amps times ohms. An Ohm's law calculator allows you to input any two of these values to solve for the third. For instance, if you know the voltage and resistance, you can calculate the current. This is vital for sizing resistors, determining current flow, and troubleshooting circuits. Secondly, voltage drop calculators are important for ensuring adequate voltage at the end of a circuit. Voltage drop occurs due to the resistance of the wires. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. These calculators take into account the wire size, length of the circuit, current, and type of wire insulation to determine the voltage drop. The National Electrical Code, or NEC, recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Thirdly, wire size calculators help determine the appropriate wire gauge for a given ampacity. The ampacity of a wire is the maximum current it can safely carry. Wire size is determined by the ampacity required for the circuit and the type of insulation. The NEC provides tables, such as Table 310.16, that list the ampacities of various wire sizes and insulation types. These calculators use these tables to recommend the correct wire size. Fourthly, conduit fill calculators are used to determine the maximum number of conductors that can be installed in a conduit. The NEC specifies fill limits to prevent overheating and damage to the conductors. The fill limits depend on the type and size of the conduit and the type and size of the conductors. These calculators use NEC tables, such as those found in Chapter 9, to calculate the allowable fill. Fifthly, motor full load amps calculators help determine the full load current of a motor. This is necessary for sizing of load protection, branch circuit conductors, and disconnects. The NEC provides tables such as Table 430.248 for single-phase motors and Table 430.250 for three-phase motors that list the full load currents of motors based on their horsepower and voltage rating. Sixthly, power factor correction calculators are used to improve the power factor of an electrical system. Power factor is the ratio of real power to apparent power. A low power factor can result in increased energy costs and reduced system capacity. Power factor correction capacitors can be installed to improve the power factor. These calculators help determine the size of the capacitors needed. Seventhly, short circuit current calculators determine the maximum short circuit current that can occur at a given point in an electrical system. This is necessary for selecting overcurrent protection devices with adequate interrupting ratings. A short circuit study is typically performed to determine the short circuit current at various points in the system. Eighthly, grounding conductor size calculators help determine the appropriate size of grounding conductors. Grounding conductors are used to provide a low impedance path for fault current to return to the source. The size of the grounding conductor is based on the size of the ungrounded conductors. The NEC provides tables, such as Table 250.122, that list the minimum size of grounding conductors. Ninthly, transformer calculators are used to determine the voltage and current ratings of transformers. Transformers are used to step up or step down voltage levels. The voltage ratio of a transformer is the ratio of the number of turns on the primary winding to the number of turns on the secondary winding. The current ratio is the inverse of the voltage ratio. Tenthly, lighting calculators help determine the appropriate number and type of light fixtures needed to achieve a desired illuminance level. Illuminance is the amount of light falling on a surface measured in foot candles or lux. Lighting calculations take into account the size of the room, the reflectance of the surfaces, and the type of light fixtures. Online electrical calculators are valuable tools for electricians, engineers, and anyone working with electrical systems. They can save time and reduce the risk of errors. Always verify the results of any calculation with a qualified professional. The types of calculations available will vary depending on the specific calculator. Some may focus on specific applications, like solar panel calculations or generator sizing. Therefore, it's important to understand the underlying principles of electrical calculations and the limitations of the calculators. Be familiar with the relevant NEC requirements and local electrical codes. Using a calculator effectively requires understanding the input parameters and interpreting the results correctly. Double-check all inputs and make sure the calculator is appropriate for the specific application. When dealing with electrical systems, safety should always be the top priority. If you are not comfortable performing electrical work, consult a licensed electrician. Electrical work can be dangerous and should only be performed by qualified individuals. Calculators are only tools and cannot replace a competent worker using safety and best practices. Electrical calculators also help with converting various units. For example, converting horsepower to kilowatts or converting between different wire gauges. These conversions are common in electrical work and can be easily performed using online calculators. Some calculators offer metric and imperial unit options to further assist with quick conversion of electrical values. Some calculators can assist with calculating the cost of electricity. These calculators can help estimate the energy consumption of various appliances and devices and calculate the associated cost based on the local electricity rates. This can be helpful for identifying energy-saving opportunities. There are other specific calculations such as calculating the impedance of a conductor. This is needed in order to do coordination studies with electrical equipment. In summary, electrical calculators provide tools for solving problems and doing conversions for electricity.